Hello everyone, welcome to massive open online course on cartographic techniques. In today's session, we will discuss about dot maps. This is the today's content. First we will discuss what is dot map, then we will see why we want to use dot map, its real world use cases, then we will see the procedure of creating dot maps. So, the steps involved in creating dot maps. Then we will do a small exercise where we will take the population density of Tamil Nadu from census data to 2011 and we will try to plot it in dot map. Then we will discuss about its advantages and limitations. So, what is dot map? So, dot map visually represents numerical data in dots to show spatial distribution and density patterns. They help us revealing geographic trends that are not easily interpreted with data and tables. So, in this class we will cover the principles, the construction techniques of dot maps and its real world applications. So, what is dot map? Dot map is a thematic map that uses individual dots to represent a frequency or a value. So, unlike other maps, dot map excels in showing both the spatial distribution and relative density phenomena across a landscape. Let us say we are doing population density mapping. Okay. In this case, we will represent the population using dots. This dots will have certain value, maybe our dot may represent 1 lakh, 2 lakh or 5 lakh population, and along with this values we will also be able to see the distribution, how dense the population is in a certain area and how much the spatial distribution is along the numbers. Okay, we can able to see both the phenomena in one map. Each dot on the map represents a fixed number of units, whether it is people or acres or any other countable features. The visual clustering and spacing of dots immediately communicates where the concentration occur and where they thin out. So, we have the population. So, for population data throughout the map, the values of each dot will be uniform. If it is 2 lakh, then it will be 2 lakh around the map. Let us say we are plotting some other amenities like cell towers over a district. Then if one dot represent 100 cell tower means throughout the map it will remain 100, it will not change, the value of the dots is fixed. Okay, so, this is an example of dot map. Here we can see the population density of United States. Here our one dot represents 2,50,000 in population. So, here we can see here in right hand side, here this region our map is closely dense and in the middle region the density is low, correct. So, even with the numbers we can see how the entities are spatially distributed along different regions. So, and this legend is important. So, whenever we are plotting the dot, the value we have to mention in the legend. Okay, so, this is 2022 data of United States population. Why we use dot maps? So, the first reason is intuitive understanding. So, as you can here we have seen the example right of US population map. So, it is visually easy to understand. So, people those who are not from technical background, those who are not from geographical background, they can also easily interpret this maps. So, let us consider people those who are from non-technical background, they can also understand in the previous example that this map shows the population and wherever the concentration is high, there the population density is high and each dot represent 2,50,000 people. Second is visual appeal. So, these have visually striking design which makes user more engaged in the map and we can also easily interpret more things compared to charts and tables. Third is pattern recognition. So, the spatial distribution and spatial pattern which is very easy to interpret in coastal, the linear arrangements in coastal regions or the urban clustering, urban sprawl, everything becomes more easy when we saw in dot maps rather than charts or tables. Next is regional comparison. So, we can interpret how this data, how this one single entity, whether this lands in acres or populations is spread across the region, different region, that is very easy to interpret in dot maps. So, now we will move on to real world applications. So, first is we will see the dot map applications in agricultural production. We can track the different types of crop production such as wheat, rice, cottons. Agricultural economists use this maps as a tool to plot out production zones and to check the supply and demand gaps in different locations. Next is epidemiology and public health. So, this disease outbreaks, where the disease is spreading, where it is getting concentrated, all this data we can interpret with dot maps. Healthcare officials use this data to supply medical demands and to strategize the prevention of these diseases. Next is demographic analysis. So, this population density map shows us the urbanization of area, movement of people. So, public sector or urban planners use this data to do the urban planning, wherein which infrastructure should be provided, which bus public service should be provided. All this planning they do with this public density mapping. So, next is resource infrastructure. In dot map we can also plot different types of resources such as wells or power stations, transformers. All the utility mapping we can do using dot maps, and also we can see where the service is lagging. Let us say we are plotting the cell towers, and the cell tower providers can see in which region our supply is lagging, and they can provide more towers in that particular region. Next is environmental conservation. So, for environmental we can track the tree plantation initiatives and the wildlife population, their movement, everything we can track over here. So, environmental scientists use this to tackle different climate change problems, and they also track to see how the restoration of forests is happening. So, now we will see the procedure of creating dot maps. So, these are the basic steps involved. First, we have to do data collection and organization. So, in our case exercise which we are going to solve now, we have taken Tamil Nadu census data from 2011. So, actually the census data covers for whole India. So, from that we have filtered out only for Tamil Nadu region, and that too we have filtered out only the total population. Okay, this data we have filtered out from the total. Then we have to select appropriate scale for the map. Then we have to determine the dot value. So, let us say we are doing for Tamil Nadu region, right. So, we will be plotting all the population as dots. So, let us say for Chennai there are 41 lakh people. So, 41 lakh people we can't mark each people with one entity, right. For one dot we can't mark it as one people. So, one dot value we can keep either 1 lakh, 2 lakh or maybe 4 lakh depending on the quantity. Then we will establish the dot size and spacing. We will plot each dot appropriately in the map with equal spacing and everything. Then we will add cartographic element, that is our map element, such as the title, north arrow, scale, latitude, longitude and so on. So, in this exercise what we are going to do is we are going to create a population density map of Tamil Nadu based on 2011 census data. So, yes, to create Tamil Nadu population density map, we have, I have already told you, right, we have filtered out Tamil Nadu population from the census data 2011. Now, what all variables we need, what all calculations we have to do? First thing is we have to calculate the number of dots, right. So, for number of dots what we will do? So, let us say in our case we are keeping it to 2 lakhs. So, that means each dot will be representing 2 lakh people. So, one dot represents 2 lakh people. So, how to calculate the number of dots is the total population of the certain area, of the specific area, we will divide it with one dot's value, that is 2 lakh. Then we will be getting the total number of dots we have to plot in each district. So, this is the data we have got from census 2011. So, here we have the district name and district population. This data we have got, and we have calculated the number of dots. So, for Chennai the total population is 41 lakh 84,738, correct. So, if we divide it with 2 lakh, so we will be getting value around, when we divide this we will be getting around 20.9, right, it is 20.98 something. So, this we will round off to the nearest value. This we will round off to 21. If this after decimal value is less than 5 means we will round off to the lowest value, that is 20. So, in this case it is 20.98. So, we will round off to 21. So, for Chennai number of dots we have to keep 21 dots, and for Kanchipuram, Velur it is 20. So, and so on for different regions. These are different district values. So, in this map we just have to calculate one variable, that is number of dots, and that too the total population value is given. From that our each dot value we will divide to get the number of dots. So, for all the districts we have done it. So, once we have calculated this, we will plot few values in the map as well. So, this is our Tamil Nadu map. Here we will try to plot all the values. So, for Kanchipuram and Velur the value was 20, right. So, we will plot 20 points in Kanchipuram district. We have to see that each dot is of uniform size. And whenever we are plotting this point, right, it shouldn't touch the administrative boundary, it should be within the boundary, it shouldn't cross the boundary or it shouldn't touch the boundary, and the point should be of uniform size. So, we have plotted 20 points for Kanchipuram. Similarly, we will plot for Velur also. So, we have seen for Kanchipuram and Velur the point value is same, the population is same, but the spatially distributed area, see, the area differs. So, the spatial density differs for both the things. So, we can able to visualize the population as well as the density of the area, correct. So, we will come to Tirvarur now. So, here the value was 6, correct. So, here we will plot 6. So, try to keep these points as uniform and as circular as possible. So, for Kanyakumari it was 9. So, we have plotted for 4 districts now, right. So, similarly, once it is done, a map will look something like this. Okay, whenever we are done with plotting all the points, this is how our dot map for population density of Tamil Nadu 2011 will look like. So, after plotting all the points, we will add cartographic element, mapping elements to it, that is our title, north arrow and legend. So, here we have to mention that 1 point represent equals to . So, without this legend our map is meaningless. This legend we have to add. So, once we add all the cartographic elements, a map will look something like this. So, this is our final map, dot map. So, now we will discuss some of the advantages and limitations of using dot map. The first strength of using dot map is the visual density comparison. Instantly we can compare how concentrated a feature is across different regions without calculating ratios. Here we can see, right, wherever the population density is more, where it is less, all the things we can immediately strike as we see the map. We do not have to calculate any ratio or do any kind of calculation, we can able to interpret it easily by seeing the map. Gradual transitions, perfect for showing how distribution change gradually across space rather than abruptly at the borders. Then dual representation, simultaneously we can able to see both the values. First is location and second is how much quantity is available in single visualization. Next is prevention of spatial patterns, it reveals natural clustering, linear arrangement and depression that other map does not show us. Okay. Now, we will see limitations of using dot maps. First limitation is it is imprecise, okay. It is not suitable where exact count is critical. So, initially we have seen, right, while calculating the number of dots for Chennai, we have round off the value, when we calculated the dot for Chennai, number of dots for Chennai was coming around 20.9, right. This 20.9 value we have rounded off to 21. So, this value is not precise, first thing, and other thing is the user won't be sitting and calculating the exact value, correct. If there is 21 point, the user is not, the people who, the end user who is going to use this map, he is not going to multiply 21 with 2 lakh to find the exact value, correct. So, even if it does that, he will get a round off value, not the exact number. So, these values are imprecise, can't be used where exact number is critical, where exact number is important, there we can't use dot maps. Next is subjectivity of placement. So, within administrative unit, dot placement involves cartographic judgment, potentially introducing bias. So, whenever we are plotting, right, we aren't plotting the map, we are plotting it exactly inside the boundary, but inside the boundary we aren't plotting it exactly where it is clustered to. Inside it we are plotting randomly, so there is little bias. Next is scale dependency. Map becomes cluttered at certain scales. Very high or low density can be challenging to represent. So, in our map only if we see the Chennai, the population is high, but the area is less, right. Here we have high population density. Here the population density is more. So, the map is little bit cluttered, and even some values are touching the administrative boundary. So, within the small region we have to plot 21 points, right. So, that becomes a little infeasible. So, these are some of the limitations of using dot maps. So, map becomes cluttered at certain scales, very high or low density can be challenging to represent. Next is large administrative units may appear artificially dominant even with low density. Now, we will see some of the essential guidelines we have to keep in mind while plotting dot maps. First thing is we have to maintain uniform size for the map for the dots, and we have to keep it as small as possible. So, we will use dots between 0.2 to 0.5 mm of diameter, and we will keep consistent the value we will keep consistent. We won't be changing the value, somewhere we have kept a large dot, somewhere small, no, we will keep it consistent between 0.2 to 0.5. Then we will avoid visual clustering or overlap. So, in the previous map we have seen, right. So, here no points is overlapping. So, each point is an individual point. So, we won't be overlapping any point. If one point touches other point, that is fine with if there is low space, but it shouldn't be completely overlapping like this. So, it shouldn't overlap like this. This looks like one single value, right. This does not look like two maps. So, if it touches little bit, that is fine. So, it shouldn't completely overlap. In the dense area, dots should nearly touch but not merge into solid blocks. Use geographic knowledge to guide placement. Population dots belong in valleys, not in mountain peaks. Next, respect administrative boundaries. So, values shouldn't be touching the administrative boundaries, or we shouldn't be placing the dots on top of the administrative boundary or outside the administrative boundary. So, if there is 9 dots to be placed in Kanyakumari, we will place all the 9 dots within Kanyakumari. We won't be placing anything on top of the administrative boundary or beyond the boundary lines. The value should be lying within the administrative boundary lines. Next is we have to give proper legend. Okay, document dot value clearly. So, our legend must have explicitly state the dot value, that is 1 dot equals to 1000. In our case it was 2 lakhs, right. The map which we created, the value was 2 lakhs. So, the value should be clearly mentioned. Okay. Without this information, our map becomes meaningless decoration only. So, these are the few points which we have to keep in mind while doing dot map, and in later class we will also be seeing how to do this in software, some advanced techniques to do dot maps using softwares also. Thank you so much everyone.